You've already attached this page to your notebook, but let's take a minute and look at some of the vocabulary in here. Hopefully a lot of these things already look familiar to you, and we're just going through and going to be switching from equations to these ideas of having inequalities instead. So you should already be familiar, and we're going to refresh about how we write and graph inequalities, and then how we can go through and can actually solve them by balancing. What a compound inequality is, graphing a linear inequality on a coordinate plane with x and y axes, how to then graph a system, and also how we can go through and come up with multiple solutions for problem situations with a system of inequalities. Just a quick reminder, you're not going to copy your notes from this screen here, but this is just an idea of how your next notebook page could be set up. Let's go ahead and review some definitions. First, what is an inequality? A statement that one quantity is less than, greater than, or not equal to another. So if you remember, you've had some inequality symbols in the past where this is then going to go through and be like less than, greater than, less than or equal to, greater than or equal to, and then technically the not equal symbol. And so when we go through and we think about this, there is a difference between saying x is less than 13 versus x is less than or equal to 13. This one here on the right is saying that 13 is one of the possible answers, whereas when we say x is less than 13, 13 is not an answer. What might be new to us is the compound inequality. And this is where we technically have two inequalities that are separated by the words and or. Let's look at the and example first that I did in purple. So this reads that x is greater than 2 and x is less than 8. It means I have to basically satisfy both of those requirements. This can also be written like so, where we have 2 is less than x, which is less than 8, because we're talking about a number that is in between 2 and 8. You know, this might be like the number of Oreos that I eat. I'm going to have more than 2, but less than 8. Okay, it satisfies both of those. Now, the or statement is exactly that. It's going to be one or the other, and I can't have a number that satisfies both. So this is saying x is less than 20 or x is greater than 70, right? So we're talking about two totally different sets of numbers, under 20 or bigger than 70. An example of this that might be is like, what if x is the temperature? And I'm thinking of like, I'm sitting around right now in jeans and a t-shirt. If the temperature is less than 20, I'll change my clothes, right? I'll put on a sweatshirt and a hat. Or if the temperature is greater than 70, maybe I'll switch to shorts. Okay, it's going to be a one or the other representation. Let's go through and look at some of the examples in the yellow paper. Let's talk about shading and graphing the inequalities on a number line. So first off, we're going to be looking at a number line, and we need to put circles to on top of the numbers to signify where we are starting or ending our shading, right? Because the inequality is going to not just have one answer, it's going to have multiple answers. So when we talk about the types of circles, we start with this basically open circle here, where this is basically going to be used with the less than or greater than symbols because it's showing that the numbers itself are not included. Whereas the filled in circle or the closed circle or the full circle, these numbers are part of the shading, so they're going to be used with the less than or equal to or the greater than or equal to symbols. And then what we want to remember is that we are going to be shading the numbers where the inequality is true. So as we look at a number line and compare it to the inequality, we'll place a dot, okay, open or closed, and then we're going to shade the numbers that are true for that inequality. Let's try some examples. Let's talk through these two, and then you can try some on your own after we look at some compound examples. So if we look at this first one where we have x is greater than 2, 2 is the number where we are starting at. So that's the number that we're putting on the number line, and it's getting a full circle because we want to keep this guy open because 2 itself is not an answer. 2 is not greater than true. That's false. Now, when we think about where our shading is going to be, we're talking about shading where x is greater than 2. Well, all numbers that are bigger than 2 are in this direction on the number line. So my purple shading there is representing all of the possible answers that it could be, and it goes on forever. Even though it might look like that 2.1 is not shaded, we all know that 2.1 is bigger than 2, so that would be included as part of our solution. Now be careful as we look at the next one below that. -4 is going to be our circle, and it is a less than or equal to, so we are going to start with a closed dot there. And then when we think about, we're looking at numbers that -4 is greater than or equal to x. Well, if you're not sure how to shade here, let's put a number in for x here and think, okay, what if I put 0 in? Is -4 greater than or equal to 0? And the answer to that is false. -4 is less than 0. So 0 here is false, which means this side is the true side. So that means when I go to shade this, I actually am going to be shading to the left here. And I know some students will say to me, but Mrs. Leptak, I always look to this symbol here and it tells me what direction to shade. And that is not always true, especially as we are adding in compound inequalities. So it's always best to sort of just stop and look and think about which side and what type of numbers would make my inequality true. When we look at compound inequalities, it basically just means I'm going to have some shading with the or statements. I'm going to have shading that is going to be going in opposite directions. So if I have x is less than or equal to -1, I'm starting with a closed dot there, -1. I will have an open dot at the 3. But again, for the shading, if I start and think about how this is going to work, if x is less than or equal to -1, I'm looking for numbers that are less than -1. That means my shading is going to be going in this direction. And I'm also looking for numbers, okay, where it is bigger than 3, right? 3 is less than x. So I'm looking for numbers like 4, 5, and 6. So my shading is going in that. The or statements are always going in opposite directions of each other. Hit pause and try the one below it. And you can see for my answer how that shading should look. Now with an and inequality, it'll look slightly different as well. The and inequalities can be written as a single inequality where it has basically a minimum and a maximum. So as we go through and we look at these statements, we have -2 is less than or equal to x. So that means -2 is one of our possible answers. Okay, and then that x is less than 4. So 4 is not a possible answer. So it gets an open circle. And then that x, that number that is there in the middle, is basically saying I have numbers, all possible numbers that are in between the -2 and 4. Okay, that is that and statement. It can be written as that one inequality. So if we take a minute and we try the bottom one, hit pause and give that guy a try. You should end up with 2 open circles because of those less than symbols within the shading in between. Hit pause and give these guys a try and check your answers. If you're getting them wrong, make sure you check in with me to double check how these are going. Try these. Hit pause and choose your best answer. Hit pause again and choose your best answer.